Good morning, mathematicians. Today we are learning the last lesson in our Unit 5 geometric series. Your objective is students will be able to find the sum of a geometric sequence. Go ahead and grab your notes and let's dive in. All right, so first thing we're going to do is review really quick what a geometric sequence is. So when we're talking about a geometric sequence, we're talking about the common ratio. That's the number you are multiplying by to create the pattern of that geometric sequence. So how we move from one number to the next is by constantly multiplying by a number. Now, some of you may have noticed that if we have division, like on the second example, 52, 26, 13, 6.5, that's dividing by 2. That always needs to be in terms of multiplication for the common ratio. So instead of saying divide by 2, we would say that the common ratio is multiplying by 1/2 because those are the same thing. If you're ever confused about this, just grab any term. For example, if we grab the term 13 and divide it by the term that came before it, 26, and 13 over 26 reduced is 1/2. And this works for any terms in the sequence as long as they're right next to each other. All right. And those would be our common ratios, 3 and 1/2. Boom. All right, again, reviewing the geometric sequence formula. This is our UN formula. UN is equal to U1 parentheses R raised to the n minus 1 power. Now, this is when we are looking for a specific term within a geometric sequence. I want the 10th term, I want the 20th term, I want the 30th term, and so on. You've already had practice with this. So then what is a geometric series? Now, geometric series is going to be the sum of the geometric sequence, very similar to what an arithmetic series is to an arithmetic sequence. We have the exact same notation. The sum of terms is notated by Sn, S sub n, and the common ratio is still notated by R. So as before with arithmetic series, we had two formulas. Geometric series, we have one formula, just it can be written in two ways. So you can see here we have Sn, that is the sum of terms. U1 is still the first term, R is still the common ratio, and N is still the number of terms. And then you can see that that is the first half of the formula. The second half of the formula is the exact same as the first half of the formula, but you can see that the 1 and the R to the N just switch places. It's just letting you know that it doesn't matter which way you write it. You will end up with the same answer either way. So I like to just ignore that part of the formula and just use this first half over and over again. Now you'll see over here, there's a note that says R cannot equal 1. And I want you to think about that. Why can't R equal 1? So if we took 1 and if we plugged that into the formula, we would have R minus 1 on the bottom. That would be 1 minus 1. And that would give us 1 minus 1 is 0. And we can't divide by 0. That's mathematically impossible. Also, if the R was 1, think about what that would mean for our sequence. If we multiply by 1, that would mean the numbers would never change. Like it'd be 3, 3, 3, 3, 3, 3, 3, or 4, 4, 4, 4, 4 over and over again, because it would not be changing. So that doesn't work. It can be any other number. It can be a decimal. It can be a fraction. It can be a whole number, but it just can't be 1. All right. So why would we want to use the geometric series formula? Maybe you like finding every single term and adding them together. You think that's easier. Well, I like to use it because it's faster. You don't need to write the entire sequence. Sorry, that should say sequence, not series. No need for writing the entire sequence. There's less error because what if you have to add to like 20 terms and you write out all 20 terms and when you're adding them up, you make a mistake? And most importantly, it allows you to solve for n. So there's sometimes where you might need to find what term is a certain sum of the sequence, and you'll need to plug it in and work backwards like we've done before. And you can't do that if you just keep going with the pattern. All right, so let's look at this example. So we have the sequence 1, 2, 4, 8. Now I want you to pause and try to solve the first two by yourself because you should know how to find the common ratio and you should know how to find U15. So take a pause and try to solve those yourself. Okay, I'm assuming you paused and now you're back. What is R? So I want to check what is the sequence multiplying by over and over again in order to make that pattern. And in this case, it looks like that's a 2. If I wanted to check, I could grab any of the two numbers that are next to each other, like 8 and 4, and divide those. So 8 divided by 4 is 2. All right, let's see here. So then our common ratio is 2. R is 2. Now finding U15, this is asking for the 15th term. What number is in that 15th position in this pattern? So I will start by writing my usual UN formula for geometric sequence, making sure that's the geometric formula, not the arithmetic one. I'd plug in all my variables. N becomes 15, U1 becomes 1 because that's our first term. 2 goes in place of R because that's our common ratio, raised to the 15 minus 1 power because, again, N is 15. And then I would just plug that into my calculator exactly as I see it. Let me do that here. 1 parentheses 2 raised to the 15 minus 1. And I get a total of 16,384. So my 15th term is 16,384. It's a very large number. And remember, with geometric sequences, that's very normal to see the numbers become very large or very small very rapidly. All right, now let's try our new formula. So now we have S4. So I go ahead and I write the series formula. Sn is equal to U1 parentheses R to the N minus 1 close parentheses over R minus 1. So I'm going to go ahead and start by plugging in my N values. So I'm going to take 4, swap it out for N. Then I'm going to take 1 and swap that in for the first term. Go ahead and plug in for my R value, which is 2 over here and 2 down here. And then I'm just going to take that and plug that into my calculator. Remember to use the fraction setting in your calculator. It makes it so much easier to type this in. So it's alpha y equals, in case you forgot. 1 parentheses 2 raised to the 4th power. And then when you do 2 raised to the 4th power, don't forget to hit that right arrow so that it comes back down from the exponent, minus 1. Because if you don't hit the right arrow after you've raised to the 4th power, minus 1 will still be in the exponent. So make sure you hit the right arrow to bring it down. And it looks like I get 15. Awesome. All right. Let's look at the second example. Now this sequence is 2, 6, 18, and so on and so forth. So again, what is R? What is U12? I want you to go ahead and try to do that one by yourself and see if you can work this out. And go ahead and try the S12 as well and see if you can work that out. So I'm assuming you pause the video. Now you're back. What is R? Well, I check what this is moving by, and I get that R is 3. And then I go ahead and solve for U12 by plugging in all my variables, swapping out N for 12, swapping out U1 for 2, because that's our first number in the sequence, and then swapping out R for 3, and then inputting 12 into N as well, again. And I get U12 is equal to, what is that? 354,294. Sweet. All right, so that one, pretty okay. Now let's try the S12 one. I'm going to use the exact same formula as before, and it looks like I'm going to have to swap out N with 12 and R with 3 and U1 with 2. So let's see what that looks like all plugged in. So here's my exact same series formula where I swapped out all of my variables for the numbers I was provided. Again, I'm going to grab my calculator, hitting alpha y equals so I can put it into fraction mode. 2 parentheses 3 raised to the 12th power, hit my right arrow so that it comes back down, minus 1, close parentheses, and now the denominator, 3 minus 1. Boom. And I got 531,440. Awesome. Now, as you start finding series of much larger numbers, like the sum of 20 numbers or the sum of 30 numbers, it is very normal for your numbers to end up in scientific notation just because they're so large or they're so small. So that will be normal. Don't freak out if that happens, okay? If you have questions about how to write scientific notation, just make sure you come see me and we can go over how to do that again in case you forgot. All right, y'all, you are ready to dive into your practice. Let me know if you have any questions. Bye.